Depth perception, spatial visualization is not my strong point. I struggle with graphing these, but it's one of my favorite lessons because this is where some of my weakest math students have come like, oh, this is easy, Mrs. Woodard, I'll go up to the board and show everyone. Because for them, that spatial visualization just makes sense. Okay? We're used to graphing in 2 dimensions. We're used to graphing in X and Y. So if you guys look, X and Y are still there. It's still that flat plane. So X is going across, Y is coming up. All right? So we still have X and Y. Well, now what we've added is we need a better...
Oh, no, I'm getting it. No.
What we're going to do now is add in the Z dimension, the 3rd dimension. We're going to add some height to these points. So we're going to plot this XY point like we're used to plotting, ladies and gentlemen. And then what we're going to do is we're going to pull it up off the paper. That's how we get 3D. So you take a flat box, and then you're going to pull it up and make a point. So I'm going to show you guys how to graph these. All right? Bear with me, because like I said, this is not one of my strong points as a teacher. So I need to graph 4, 2. That's my first step, is to graph where X and Y intersect. And it's going to be on this plane here. All right? So I'm going to go 4. This is my positive X. This is my negative X. Okay, think of it as like you're kind of staring down the side of your graph paper. Here's your origin. Positives are to the right, negatives are to the left. This is positive Y, and this is negative Y. So those would be important things for you to write down so you can look back at that. So label your positive X and your positive Y. So if I need to graph the point 4, 2, I'm going to go 4 spaces positive on the x-axis. 1, 2, 3, 4. And then I'm going to do positive 2 on the y. 1, 2. And so I get this point right here. So the graphing doesn't look a whole lot different for that first part. I'm going 4 on the x, and then I'm going up 2 spaces on the y. This point, guys, isn't part of our final answer, so I really probably shouldn't have made it that big. I make it it's kind of like a little just placement. Because what we're going to do is we're going to take this point 4, 2, and we're going to add in height. And because this is a positive 3, it means I'm going to pull it up 3 spaces. If it was negative, guess what we would be doing? Pulling it down. So we need to take this and pull it up 3 spaces. So this is where, like I said, trying to give you guys a way of visualizing it. We're not just going to count up 3 spaces on the z-axis. Okay? What we're going to do is we're going to take this point, and I usually follow this y-axis right here. Follow that until you hit the z-axis. So I kind of take my green, I'm kind of making this box. So I take it back until I hit the z-axis. That point is hitting the z-axis right here. So then from that point, I'm going to go up 3 spaces. So I'm going to go up 1, 2, 3 spaces on the z. And then you're going to kind of draw out this little box. Let me stand over here. You're going to create this little rectangle here, guys. And so right here is where our final point is at. And that does look a little off. I think I brought it up too far. Sorry guys, I brought it up a little too far on mine. I'm going to try and keep these sides parallel. And this is why this is a hard lesson for me to teach, because I have to step back from my paper to see it. But what you're trying to make is this parallel box here, dragging this point up 3 spaces. All right, ready to try another one, guys? All right. Let me look at what's on my graph next. Do I have another graph here to do it? Nope. All right. So I need to erase and start over. All right, I need to graph -3 on the x, +2 on the y. So I'm going to go -3 on the x, 1, 2, 3. +2 on the y, 1, 2. And this is my little marker. I need to pull that up 5 spaces because z is a +5. That's a z. With making cursive ones. All right, is that a better z?
Sure.
It's about as good as it gets. All right, I need to figure out how to move this up 5 spaces. So I'm going to take this back. It's a different color. I'm going to take this back until I hit the z-axis. I'm going to count up 5 spaces. Now, depending on some of our problems, guys, we may go off our graph, and that's okay. I'm going to count up 1 space. I'm in the middle. 2, 3, 4, and then I'm going to go up 5. And remember, we want to keep this rectangular shape. So I'm going to drag my point up until it's even. And so where that corner of the box ends up, this is my point. -3, 2, 5. That's what it looks like. You're getting up off that graph paper. For some people, and that's why I said this is one of the best and sometimes one of the most frustrating lessons. So what I want. All right, ladies and gentlemen, to me, one of the most difficult things with this lesson is figuring out this graph. And so I was just looking at it with someone and said, okay, how do we remember which one's positive, which one's negative? Because that x-axis is usually what throws me off. Z going up is positive, going down is negative. And that still fits our common sense, right, guys? Up should be positive, down should be negative. If you look at this y-axis, think of this y, this is our y-axis. Positive is going to the right, negative is going to the left. That still fits our common sense, correct? So what you're going to have to do is kind of physically picture yourself standing at the origin. If y is going positive this direction, x would have to go positive towards me and go in this direction. So you're going to have to get that x-axis orientated that way. The fastest way to do that is that when you're doing these problems on every one of your graphs, go through and label positive and negative, positive, negative, positive, negative. That way when you get to the quiz on Tuesday, it becomes second nature. So don't just look back at your notes each time. Physically put those positives and negatives on there.
That little red mark, that's not a...
No, I was just underlining where x and y were at.
Yeah, okay. So it does go alternates around. It should never have a positive and negative next to each other.
Actually, we do. We have two positives. Oh, I see what you're saying. Positive, negative, positive, negative, positive, negative. Very nice, Mr. Clem. I have never noticed that in the 4 years I've been teaching this. Thank you. Did everyone hear what he said there? All right, it goes around the horn. Positive, negative, positive, negative, positive, negative. Amazing. We taught this together last year, and he didn't give me that hint then.
You know what? You made me go out with someone. That's why I'm learning this right now, because I was helping someone like, no clue.
All right, so now what we're going to do, that's how traumatic this lesson is. You can even remember that from last year.
Oh, yeah.
We need to graph in a 3-dimensional plane. 2x minus 2y plus 3z equals 6. What we're going to do is we're going to find where all the points intersect their axes. You're basically finding x, y, and z intercepts now. If you remember how to find intercepts, guys, that means for the x-intercept, y will equal 0 and z will equal 0. For the y-intercept, x will equal 0 and z will equal 0. And for the z-intercept, is it on your notes, guys? It should be example 3 on the notes. And then the z-intercept is x is equal to 0 and y is equal to 0. Okay? Well, the easiest way to do that, and I think I had someone use this phrase with me yesterday, we're simply going to use the cover-up method. Alright? So to find my x-intercept, if y and z are 0, those are covered up. You're solving the little equation, 2x equals 6. What's my equation going to look like for my y-intercept? Well, I cover up the x and z, so what's my equation going to be? Negative 2y is equal to 6. And for my z-intercept, if x and y are 0, I cover those up. And I get 3z is equal to 6. So go through and just quickly solve those. It just ends up being a nice division problem, doesn't it, guys? So x-intercept will be what? 3. What's my y-intercept going to be? Negative 3. And what's my z-intercept going to be? 2. Well, ladies and gentlemen, these are actual points on your axis. So we're going to take and plot 3 on the x-axis. Remember, this is positive, negative, positive, negative, positive, negative. Thank you, Mr. Gluck. That helps out. So I'm going to go to positive 3 on the x-axis, and I'm going to put a point. I'm going to go to negative 3 on the y-axis, and I'm going to put a point. I'm going to go to positive 2 on the z-axis, and put a point. 3 dimensions, ladies and gentlemen, now creates what's called a plane. So it's an actual figure. So we are going to connect these 3 points, and we are going to create a triangular shaded region. Let's try example 4. I'll go to a split screen here so some of you can copy that down. So we want to graph 5x plus 4y minus 10z equals 20. Austin Hoffman, how would I find the x-intercept? 5x equals 20, so we do 20 divided by 5 and get x is equal to 4. Beautiful. Dominique, how do I find the y-intercept? So 4y equals 20, so y equals 5. Shane, how would I find the z-intercept? Good job. Negative 10z equals 20. So you get z is equal to negative 2. Label your graph positive, negative, positive, negative, positive, negative. So the x has a 4 as the y-intercept. 1, 2, 3, 4. Y has a 5. 1, 2, 3, 4, 5. And z has a negative 2, 1, 2. Connect those. We get a really, and I think you guys on your graph paper get an even smaller one, a really skinny sliver. Am I correct, guys? All right. What I would like you to do now is I would like you to try number 4. Let's do number 11 on your own. Skip spaces on your graph. And this one to me is pretty easy because we're going back to just regular old algebra. And in fact, this is what Dominique was doing on his own. Okay? Yeah, you were doing the solve for z. Ladies and gentlemen, have we solved for y before? Yeah, when we did y equals mx plus b, we've isolated y. What you need to do now is you need to isolate z. So how do you think you're going to isolate z in this equation? Well, I've got to get rid of 3x, so how do I get rid of 3x? Minus 3x from each side. How do I get rid of minus 9y? And 9y. This is on the back side of your notes, guys. Sorry. So you're going to have 3z is equal to, I don't care what order you write it in, guys. You can write it in standard form, so you have x, y, and then the constant. Or you can write it as just 6 minus 3x plus 9y. Just like when we were solving for y. It didn't matter whether the x came first or not. Now, how am I going to finish getting that y by itself?
Divide by 3.
Divide by 3. On every single term. That's all that 3D graphing has done, guys, is it's added that extra step there. So we're going to have z is equal to 2 minus x plus 3y. So this is what z equals. And so then, what's the second part? It says solve the equation for z, then do what? Evaluate it for the function at 1, 2. Now, we were used to evaluating, guys. We did this in lesson 2.8, I think. We said evaluate the function at f of 2. That meant we plugged 2 in for x, correct? So if I have the function at 1 and 2, that means I can plug in 1 for x and 2 for y. So we're going to go back to this equation. We're going to keep the 2. We're going to minus 1 for the x. We're going to add 3 times 2 for the y. And that's going to equal z.
Wait, isn't that a z?
No, this is my 2. I don't have very good...
Oh, I switched the order. Okay.
Okay. No, that's...
I see what you...
It's my handwriting.
No, I was,
Christian, you got your hand up like you're thinking, or... Okay. So are we okay getting z by itself, guys? And the only difference is now, because I have both x and y in the equation, I have to have 2 values to plug in for it. So they give me my ordered pair of 1, 2. So I plug that in. 2 minus 1 plus 6, if I do a little bit of mental math here, should be 7, am I correct? You guys getting 7? All right, that's it. I'm not going to have you guys do the last example. I'm going to have you guys go to your homework, and I would like you to do problem number 1.